Welcome to VidyaNest. Today we are going to start a new chapter, limit. Class 1. First, we have to understand what is the basic concept of limit. Suppose you have taken a number, say x is equal to 1 plus 1 by 1, 1 plus 1 by 2, 1 plus 1 by 3. In this way, number is being increased and you have got 1 plus 1 by n. That means if n is increasing, then the number is decreasing and tending to 1. Then x is tending to 1. Okay? X is tending to 1. Like you know, in recurring decimal, in junior class you were taught, say x 0.9, then 0.99, 0.999. So if you continue like this, so many nines are coming, but it is not actually 1, but tending to 1, Okay? So,
Yes.
then this 1 is called limiting value of 1. This x 1 is called limiting value of x. Say, if I draw the number line, this is 1, you are approaching 1. 0.9 recurring, it means it is about to meet 1. It is about to meet 1. So this part which is approaching 1 is coming from left hand side of 1. So it is called left hand limit. Left hand limit. Okay?
Okay.
When what is the basic difference between 1 and that value would be 1. 1 and this value. See, there is a term, it is called epsilon. Epsilon is pre-assigned least positive quantity no matter however small. So, if that value of 1 and 0.999, that thing, the difference between 1 and this value, if lesser than that pre-assigned least positive quantity, which is called least, what is its value? That depends on you, how much lesser it can be. Okay, say 10 to the power minus 100 we can take. So small. If that difference is lesser than epsilon, then you can say that x, which has this value, is about to fall on 1. Means in that case, limit of this value x tends to 1 will be 1. Now, this is called left hand limit and that is called right hand limit. Why? Because 1 plus 1, 1 plus half, 1 plus 1/3, gradually the number is decreasing and approaching 1. So this is called right hand limit. Now, if left hand limit is equal to right hand limit, means if 1 plus means what? Plus 1? No. 1 plus means right hand side of 1, f1 plus is equal to f1 minus, then you can say limit exists. Then you can say limit exists. Suppose you are going to school. From in the front gate of your school, one side, that is left side, another side, that is right side. Students are
Yes.
coming from left side and few students are coming from right side. If the school is open, that means you can meet. That means on that case, your limit exists. But if school is closed, that means left hand limit and right hand limit could not meet. That's why in that case, limit will not exist. Okay? So hope you
Oh,
understand the existence of the limit.
sir, here f minus 1 means left hand limit
Yes.
and f plus 1 means right hand limit.
Yes, if they are equal, and 1 plus means not plus 1. Right hand side of 1, 1 minus 1 means not minus 1. Left hand side of 1. Okay? From
Okay, sir.
this way, from this side, someone is approaching a point, and from this side, someone is approaching a point. If they meet, that means limit exists. Understand?
Yes, I got it.
Okay. Now we will frame the definition of the limit from that concept. See, suppose there is a curve y is equal to fx, and what curve it indicates? Any curve, obviously. I am telling you that, see, this curve I am referring, see, this is x and y. I am referring by this curve the study time and result of a student. If x is the study time, y be its result. Suppose one student is spending a times, x is equal to a. Okay? Then he or she can get marks L. So this
Okay,
point
sir.
must be what? A comma L. Okay?
Okay, sir.
Here x is A, y means fx is L. Now, one student has increased the time. How much? Del. Del. So now the time is spent how much? A plus del. If the spending time for study is increased, obviously the result in board will go high in class 10. It has become A plus delta. How much increment? I am letting that epsilon. L plus epsilon. Okay. So if the student is spending delta more time, then marks will become little bit higher. Previously, the standard marks was L, then it
Yes, sir.
has become L plus epsilon. Now, few students who are for the time being derailed reduce the study time, same study time. Then for them, how much is the spending time? X is equal to A minus delta. Obviously, for them, their performance will be declined. And see, here performance we had seen incremented, here decremented. And for this example, for this instance, I am taking the increment and decrement with uniform amount. See, delta time is reduced, so max is also reduced, epsilon. So those who have spent a minus delta time has got L minus epsilon marks. This part is L minus epsilon. Okay.
Okay, sir.
Now the class 10's result is out, and after class 10's result, maximum students get relaxed. So the students who are uh, whose status is that position now got little bit relaxed, and few of them are gradually decreasing the study time which had increased to achieve that marks. So once they pursuing decrement of study time, then along this graph their performance will
Decrease.
become reduced. Yes or no?
Yes, sir.
And those students who stays here have got trash at their home, and their parents are saying, okay, you have got this marks by spending this time, you spend more time, somehow you have to get a standard marks, not that level of marks, standard marks. Otherwise, very difficult to find a place in society. So those students were somehow displaced from their status, now spending time more. Obviously, their performance will increase. Yes or no?
Yes, sir.
So those students who got good, extraordinary marks and somehow relaxed after 10, they are reducing their time, so their performance declining, and they are tending to that modest level marks in class 11, and those who got poor marks for the time being are spending time more and reaching that standard level, okay, for them. So what we have seen from this side means x is equal to a, x is equal to a, and a plus delta time. Maximum time was spent, a plus delta. Minimum time is a minus delta. And here x is equal to a. That is the standard time. And
Yes, sir.
that is the spontaneous increment of the serious students and decrement by the little bit derailed students. Now these time are coming closer to each other because delta is reducing, so their study time is increasing, their study time is decreasing. Yes or no?
Yes, sir.
So the performance of the students who got L plus epsilon marks and who got L minus epsilon marks are also coming closer, because performance depends on the time spent by the student. Okay, so
Oh,
that part is called right hand limit. This part is right hand part of the domain, and this is right hand part of the range, So here that inequality can be rewritten. How? See here, if I take the right part of the inequality, x less than a plus del. So I can write x minus a less than del. Okay? And
Okay, sir.
take the left part of the inequality. A minus del less than x. That means a minus x less than del. Take minus common, x minus a less than del. So here we got plus x minus a. Here we got minus x minus a. So just recall your memory. In function we got mod, the concept of mod. Mod x will be x if x greater than 0. Mod x will be minus x if x less than 0. So plus x minus a and minus x minus a combinedly give us mod x minus a less than del. Okay?
Okay, sir.
That means from this neighborhood, time is incremented time and decremented time are coming closer. Incremented and decremented time are coming closer. Therefore, the incremented marks and decremented marks are also approaching each other, and once they meet at fx is equal to L. Yes or no?
Yes, sir.
Then L will be the limiting value. So, in the similar manner, if I take that inequality, fx less than L plus epsilon, bring L in left hand side. And if I take that part, L minus epsilon less than fx, so L minus fx less than epsilon. So instead of this, I can write minus fx minus L less than epsilon. So plus fx minus L and minus fx minus L togetherly give us mod fx minus L. Yes or no?
Yes, sir.
So what we have observed, as the difference between x and a is being reduced, then the difference between that fx of that state position and fx of this position will be reduced, and once they will meet. So we can say in that case, both the students of both status have got their limit, means somehow got a standard marks. So I suggest the students community not to follow this, because always stay at this position. Don't come down. So,
Okay.
okay. See, so what conclusion I can draw? If x and a less than delta, what is delta? A small positive number. Delta is a small positive number. If that thing implies fx minus L less than epsilon, where epsilon's definition already we have got pre-assigned. Least positive quantity. Then limit LT extends to A. X and A's difference is being reduced. Then fx will become L. That is the definition of the limit. It is called epsilon delta method. It is called epsilon delta method. Definition of the limit. Understand? Suppose you have
Yes.
got x tends to 2, fx is equal to 3. Then if you are asked what was fx, fx is also exactly 3. No, fx was slightly greater than 3 and slightly lesser than 3 and slightly greater than 3. Okay, from both
Okay,
sides
sir.
approaching which value? 3. That's what is the limiting value. Where time, that x slightly lesser than 2 plus delta, 2 minus delta. Understand? This is the
Yes.
formation of the limit. Okay.
Okay, sir.
Now, using this definition, sometimes any student can write, instead of LT, they can write lim in short form. Lim is also limit. Okay.
Okay, sir.
So that is definition of the limit. Definition of limit by epsilon delta method. Now we can defend one sum of limit using this definition. See, suppose you are told to find x sine 1 by x. X sine 1 by x. See, you can do it by any way. But I am explaining this with definition of the limit. We know sine 1 by x lies between +1 to -1.
Yes,
Okay,
sir.
because we know the range of sine theta, +1 to -1. Yes or no?
Yes, sir.
Now, what about x sine? So if you want to express it by mod, plus and minus both have to be included. Mod of sine 1 by x less than equal to 1. But there is one extra x appended. So you multiply both sides by x. Okay?
Okay, sir.
Now, by the basic property of number theorem, mod A into mod B will be mod AB. So, mod X okay.
Okay, sir.
Now, what is given? X tends to 0. X tends to 0 means mod X also tends to 0. So, it is the nearest value to 0. So, I must say it is less than epsilon. So, x not exactly 0. See, mod x is not exactly 0, but nearest to 0. But what is that nearest value? We cannot fix. It is, non-measurable. Okay. But we
Okay,
can
sir.
feel, we can comprehend. So, it must be lesser than epsilon. So, I can write x sine 1 by x. If I write a -0, that will not make a difference. This -0. Now, it is comparable to what? The definition of the limit fx minus L less than epsilon, where x tends to 0. So, L is what? 0. Therefore, limit x tends to 0, x sine 1 by x is L. L is what? 0 over here. That is by definition we have done. Okay.
Yes, sir.
Now, when you will do limit, you always remember one thing. Suppose you have got limit of two functions which are in additive form or in deferred form. So you can split them into two parts. It is, basic concept. If they are in product, then I can write them separately. And obviously, if they are in division form, I can write separately. Okay?
Okay, sir.
Now the question is that x tends to a is given. Question is what? Can I put x is equal to a? Obviously, I can put in division form. Obviously, I can put x is equal to a. If GA, suppose I am putting a in place of x. If GA, if not equal to 0, GA is not equal to 0, then you can put a in place of x. Or by putting x is equal to a, if you get 0 by 0 form, then you will not be allowed to put the limiting value directly. Understand? Suppose you have got limit x tends to 1. First, we will put x is equal to 1. You can ask me x is not is equal to 1. How can you put? You should put the nearest value to 1. But what is that nearest value? We don't know. So, we will put x is equal to 1, though we know the limitation that what is the nearest value of 1, it is cannot be measured. So I will put x is equal to 1. But here if you put, you see 1 minus 1 0, 1 minus 1 0. So it is attending 0 by 0 form. Yes or no?
Yes, sir.
That means we are not allowed to put x is equal to 1. So it demands simplification. So x plus 1, x minus 1, that will get cancelled. So that 0 part is removed from denominator. 0 part removed from denominator. You have got x plus 1. Now you can put a, x is equal to 1, subject to the matter that whether you are getting a finite value or not. Yes, if I put x is equal to 1, I am getting finite value. Then you can ask me where that method is discussed that x is equal to not equal to 1 exactly. Actually, x not equal to 1, but the sake of calculation we are taking 1. So, as a side note, you have to write x tends to 1, x not equal to 1. You have to make the examiner understand that you know the concept of limit, not blindly you are putting x is equal to 1. Understand?
Yes, sir. Sir, can we take other value than 1?
Yes. Had it been other value, then it is okay. But here x tends to 1 and x minus 1 is given in denominator. So if I am putting x is equal to 1 directly, then I will get 0. So that is, that is calling what? The concept of infinity or undefined result. But limit,
Yes.
we are doing limit chapter. So it must have finite value. So I can't put x is equal to 1 directly. But had it been x is equal to 2, x tends to 2, then you would have tried by putting x is equal to 2, you would have got a finite value. Then you could have uh, put this x's value directly. Like x tends to 2 in the same sum. if I put x is equal to 2 directly, shall I get 0 in the denominator? No. So I am entitled to put x is equal to 2 directly, because here if this is fx and this is gx, which we have just discussed few minutes back, here g2 is not equal to 0. So it is 4 minus 1 by 1. Answer 3 directly you will get. But here you can't do that. Okay?
Yes, sir. Got it.
Okay. So that is the basic knowledge of limit. Now there is one interesting thing. What interesting thing? We will recall one theorem that is called sandwich theorem. What is that sandwich? By spelling with not matching with normal sandwich. Okay. So, and it has other name. Squeeze theorem, squeeze play theorem. What is that? See how it is, though it differed by differed by spelling with normal sandwich which you are eating. See, suppose there is a bread, in the uppermost, there is a bread in the lowermost layer, and in between two breads, vegetables. Veg sandwich you are having now, suppose. Vegetables are there. So, if someone is having this sandwich, then how can you describe that event to your friend? Okay, the uppermost bread is eaten by your friend, and lowermost bread are also eaten by your friend. That means it is our easy conclusion, the vegetable part of the middle is already being eaten. Yes or no? Is uppermost
Yes.
is eaten, lowermost is eaten, so middle part also be eaten. Yes or no?
Yes, sir.
So you drag this concept in math. This is, suppose, hx function. This is gx, and between two function, another function fx is squeezed. So if limit x tends to a, the limiting value of the uppermost function, that is, infimum, supremum, limiting value of the lowermost function, infimum, if equal, then limiting value of the middle function is also same. This is called sandwich theorem or squeeze play theorem. Understand? Sandwich
Yes, sir.
theorem or squeeze play theorem. Understand?
Yes, I got it.
Now, does it have any application in maths? Obviously, in jugglery of theorem, in bookish knowledge, it has direct application. But does this theorem refer any direct sum which can come in board or JEE? let us discuss one sum of this type. Let a function maps from real number to 0 to infinity. Means domain is real and codomain is 0 to infinity. 0 is not included. Open interval means 0 is not included. Be such that fx plus e to the power x plus x square by fx fx plus e to the power x plus x square by fx less than equal to e to the power x plus e to the power x square. E to the power x plus e to the power x square for all x. This symbolizes for all x. Okay? For all x
Oh,
greater than 0. For all x greater than 0. Then limit x tends to 1, fx is option A 1, option B 1 by e, option C e, option D 2ic. Apparently, this sums seems to us very gigantic, but actually the simplification demands the basic algebraical grip of class 7 middle term factor. Okay? How? Just see. Just fx plus now you take the LCM. So easy approach is taking LCM. Fx whole square. This implied what? That a to the power m plus n formula. Hope you are taught in class 9 a to the power n plus n means a to the power m into a to the power n. Here e to the power x, e to the power x square less than equal to cross multiply okay, by simple cross multiply method we have got this. Now you bring all the terms in left hand side and keep 0 in the right hand side. You will get what? Fx whole square minus okay. Now this sum demands middle term factor. Okay, you remove the brackets, simplify and get factorized. Hope it is visible now. See,
Yes, sir.
fx whole square minus plus minus so from these two I can take fx common. What will be left? And from these two so this is the factor. Inadequate place, so I am shifting here. You see, less than equal to 0. Okay. Now, once you get that factorized form, then we can use the concept of wavy curve method. What is wavy curve method? You are taught in function even. Suppose x minus 1, x minus 2 less than 0. Then by plotting on number line, we can say x lies between 1 and 2. But here 1 and 2, by seeing you can cultivate or recognize which is bigger. Obviously x lesser than the bigger number and greater than the smaller number. But in e to the power x and e to the power x square, which is bigger, without drawing graph, next impossible to say. What is the graph of e to the power x? E to the power x's graph is what? E to the power x is like that. And what is e to the power x square? E to the power x square is, in left hand side it will be lesser and right hand side bigger. Okay, this is e to the power x, e to the power x square. Now, you tell me that which part of this graph should be taken? Left part or right part? You observe the question. You see, x is given greater than 0. So I will take the right part. Okay? Yes or
Okay,
no?
sir.
So
Yes,
in
sir.
right part, which is bigger? Which lies above e to the power x square? Yes or no?
Yes, sir.
So e to the power x square will be considered as bigger number, a bigger value. E to the power x will be lesser value. So fx lies between e to the power x square and e to the power x. So it gives us the semblance of sandwich theorem. It gives the C sandwich theorem, that is the uppermost curve, lowermost curve, fx is squeezed or sandwiched between these two curves. Understand?
Yes, sir.
Now sandwich theorem states what? Few minutes back we discussed. Sandwich theorem states that if fx is squeezed between hx and gx and x tends to a, hx is equal to x tends to a the limiting value of outermost curve and low, least curve are equal the limiting value, then the function which is squeezed between these two will have same limiting value. Okay, already we have got, but here we see whether that will play any role here or not. See, fx is squeezed between these two curves. Here we are told to find the limit at which point x tends to 1. Yes or no? Let us
Yes,
take
sir.
the uppermost curve, e to the power x square. I told you few minutes back, the limiting value means the value to which x tending to. You can put directly, if you get a finite value, means limit. Its dictionary meaning means it converges to a finite value. That's why limit. Even in our daily life routine, we can say, hey, you are crossing your limit. That means you are crossing your limit means you have forgot your demarcation line. So if I put x tends to 1, x is equal to 1, I will get E. Then I put the same in the lowermost, that means the function which is called infimum. That is also E, e to the power 1 E. So by squeeze play theorem or sandwich theorem, therefore by sandwich theorem, we can say the middle part fx limit x tends to 1, fx has also the same limit. Yes or no? So
Yes,
option
sir.
is C. Okay.
Okay, sir.
If any doubt arises, don't hesitate to ask me.
Okay.